Good evening. Welcome to Ask the Lady Electrical Inspector podcast. I am your host, Tabatha L. Tonight, I will start with the most common reasons service installation inspections fail. The last few weeks, I have walked you through the process of a new commercial job in the process. So, the last few weeks, I've walked you through what it takes for a commercial job to what are some of the common things that I have failed commercial inspections for. So the first phase we walked through, we did ground rough covers. The next part of that process was wall covers. The next part we discussed was ceiling covers. Now we are at the part of the job where you want to energize the service. So tonight, that's what I want to discuss, some of the common reasons why electrical service installations fail inspections. First off, I just want to tell you what electrical service installation is. So you've gone through this entire process with the ground roughs, the wall covers, the ceiling covers, and now you want to energize the electrical work that you have put in. So now we're at the point of the job. It's the truth time. Now we're going to see what all of the hard work is about, because it's time to energize the service, and that's the service of the entire structure that you're working on. So one of the first things that I do when I come on a job site, and one of the things that not often but sometimes I fail inspections for, is if you don't have a roof on your structure. It's impossible for you to get electrical service inspection passed without a roof. So that should be the first thing that you take in consideration when you call in electrical inspection for your service. Now, a few times I'll have the electrician say to me, well, we knew you were not going to pass it, but the GC wanted us to call it in. And we know you're not going to pass it. So we just need you to tell the GC that it's not going to pass. Well, I'm telling the GCs that you need a roof on the structure before you call it in for it to be energized. Another thing that it fails for instantly when I walk on the job, and this is before I actually look at the electrical service. Roof, number one. Two would be a door to control authorized personnel entering that electrical room. If you don't have a locked door, the inspection will fail as well, because only authorized personnel is required to be in that space. When you're on a large construction job, you have so many different trades. You have so much going on that the objective is to protect the system. And the only way you can do that if it's controlled by authorized personnel, and that authorized personnel is the electrical contractor and his people. Those are the only people that's authorized to be in that space. So those are two reasons that it will fail instantly when I walk on a job site. Now, most of the jobs that I'm doing with the new construction, 90% of those jobs are underground, which means you have your service conductors are going under the ground. So with that being said, is the equipment suitable for the location? The equipment is protected. So now we're inside of the space. I'm going to look at the electrical switch gear. So I'll go back outside because I like to look outside as well. I'll start at the meter. I'll see if anything's okay, if everything's okay with the meter. Most commercial jobs where the meter is located, it always, I would probably say 90% of the time, it requires a ballard or some sort to protect it against physical damage. And if you have switchgear outside, you're going to need to protect that as well. So that's on the outside with the service meter. If it's coming into underground service, it's required to be protected against physical damage. So with that said, with the switchgear being outside or inside, either way, the first means a disconnect. The one thing that I look for with the question I said is the equipment suitable for that location and is it protected? So that would mean the ballards, and suitable for that location would mean the environment that it's in. Do you have outside rated equipment, which you probably will have that. I haven't caught that too many times. But one thing that I catch a lot when I'm doing service installation inspections is the equipment suitable for service equipment. Now that has to actually be on the equipment. It will tell you if it's suitable for service equipment or not. I'm going to talk about that a little bit later, and I'm going to stick to the ballards. The electrical equipment must be protected against physical damage. That's Article 110.27. You got to guard the live parts, 50 volts or more. And then Section B of that article states that the location where the service equipment is likely to be exposed and to be damaged shall be protected. So some of those things are the service meters, the switchboards, the panels, transformers. If you have them outside or inside, it has to be protected against physical damage. The conduit, that has to be protected. And some of the things that you're protecting it from is the loading dock. The loading dock, the truck, the trash truck, utility trucks, delivery trucks, just different things that requires protection. And we got to take into consideration the height of the cars, because that's been a question, like how far up can you go before it's not protected? Like for me, that's just depending on how high the garage is, and you have to figure that out yourself once the equipment is installed. We'll get together and we'll figure that part out. Okay, another thing I look at when I'm on a job site, how many services are on this job site and where are they located? So the number of services, like I mentioned a few weeks ago, most of these construction sites now are multi-purpose buildings. So they have several services. They can have upward of 3, 4, 5, however many facilities they're going to feed, they can have that in those structures. Because now you have all of these construction buildings that are coming up. You have office spaces, and then beneath those office spaces, you have restaurants, you have different companies that are just, it's a multifaceted building. Some of them have daycares, some of them have eating places, some have gyms. It just depends. So with that being said, each one of those tenants, that's a different service for each tenant. So you can have many different services, and that's something that I need to know when I come on that job site. Because if you have different services, that means that you have to start over with all of your bonding and grounding. So that's why I'm asking you that question. How many services do you have? How many meters do you have? Because each one of those are individual. So if you have 2 3,000 amp services, you have 2 600 amp services, you have 2 400 amp services, each one of those services act in an individual. The important thing there is the grounding and the bonding. I want to make sure I stay on task, and they must be grouped together as well. So the reason I mentioned the grounding and the bonding and the separate services is because each one of those services, if we go back to the 3,000 amp service, this is something that I have failed on multiple occasions. When you have these many number of services, your grounding, because I'm going to look at the drawings, and I'm going to make sure that everything that's on your one line and in your schematic drawing is met. That requirement is met at that time. So most of the time, they always have the grounding, but it's where you ground it at. That's been the problem. Each switchgear or each service, if you have a 3,000 amp switchgear. Now, when you go to that switchgear, you have a space in the bottom of the switchgear that tells you where to land your grounding wires. The switchgear is connected together by bus. So you have, and it's labeled down there to tell you water ground. It'll tell you different grounds. So at your switchgear, that's your first means of disconnect. Outside, you have the meter. Inside that first switchgear, you have to bring your main water grounding electrode to that gear. In each section, each 3,000 amp breaker has to have a water ground and all of the other auxiliary grounding. And then once you hit the water ground in your switchgear, then you can daisy chain off of that and go over to your auxiliary bar, because that's the main. And you don't want, if a fault happens, if anything happens to your auxiliary bar, you will have some sort of main or backup for that system. So just keep that in mind, because that's something that has failed several times, where you land your water ground. And it's under the assumption, I don't know why, but they think that you only should hit your main switchgear once. But if you have 3,000 amps and then you have 3,000 amps over here, and those are two different services, the grounding starts over. So when I go back to look at the water meter, I should see two water grounding electrodes. So the maximum we allow is a 3-odd copper or a 250 aluminum. So with 3,000 amps, you already maxed out. So that's something I want to address, because that has happened on several of my inspections. And I just want to make sure we understand each other on that. And if you have any questions, please give me a call or email, and we can discuss that. So when I'm there, I'm going to look at the approved set of plans before we energize, like I said, the one-line diagram. And so I'm going to also check the current rating, the voltage rating, the short circuit current rating of the service equipment. I'm going to check to see if, like I mentioned earlier, if it's suitable for service equipment, because those panels that are suitable for service equipment, it's the way it's bonded, because you can have different types of panels. It depends on what the objective is and what you need that panel for. So if it's a service panel, it has to be bonded. It has to be bonded right there before you disconnect the bond for your sub panels. So in that main electrical room, your equipment has to be suitable for means as service equipment. It has to be written on the gear. It has to state that. And if I can't find that language, then we have to find it. And most of the time, they'll go and they'll get the manual. And they'll say, well, hey, let's look in the manual, but it has to be affixed to the product. So it has to be on there. So that's something that I have failed inspections for quite a bit. And everything on the plans, like when I'm checking the plans, everything on the plans must be the same. It can't be any discrepancies. So if the plan calls for a 2,000 amp breaker, you can't have a 1,000 amp breaker installed. You can't use that as a substitute. So just remember, I'm going off the approved set of plans. So then some people may ask, what is an approved set of plans? Those are engineering drawings. So someone designed this project, and they got together with an engineer and another team of people, and they approved of this electrical system by meeting the minimum requirements of the National Electrical Code. That was the point of doing this. But once it has been approved, it's written in stone because someone has signed off on this. And I have to make sure that you follow that, because if you don't follow it and I don't make you follow it, then if anything happens, you didn't go off of the approved set of plans. So if you can't deviate from that, and that's a problem sometimes, that you would have to get a RFI if you needed to do a revision or some sort. So with that being said, I have a question. Okay, so another thing that I look for when I'm doing the inspections on service equipment is while I'm in there. Now it's a good time to look at the seismic requirements, because remember, someone designed this, and the seismic requirements are my municipality, my jurisdiction. We have our own set of seismic requirements, as well as the manufacturer. They'll tell you some things to do with their equipment as well, because the seismic requirements is for earthquake protection, like to make sure that under the event of an earthquake or anything like that, that the equipment won't topple over, or is designed to make sure that the boats that you use can handle any severe vibration. So that's what the seismic requirements are for. And the seismics are designed for switchgear to protect, like I just mentioned, disasters and limit damage to the electrical equipment. So the seismic requirement for switchgear. Okay, so like I stated with the municipality and our jurisdiction, we have our own. And then also you have a UL91 is the most popular, the most common standard for switchgear and switchboards. And it applies to those rated over 600 volts or less. And it's in accordance to the National Electrical Code. So with that being said, that's a good time to make sure that everything is tightened, and the bolts that are required, 1/2 inch, 3/8, whatever the engineer tell you to use, that's what you need to use. The length is required. So when I come on site, have that available, because I'm going to ask that question with the seismic, and I need to see the bolt, because remember, if you've already drilled and put it in place, I don't have a way to back it out and see what you use. Only I can go off of your word if you have the box there to show me what you installed, and I'll take your word for it, because I don't have another choice. Okay, so now I'm going to verify if any of the equipment connected to the supply side of the service is permitted to be on the supply side. Now, what that means is that the supply side, that's the utility side. So when I come in, and if I see a bus and I see some shavings, and I'll ask, well, what's going on? Because this has happened, and this will fail inspections. And then we'll pull out the one line, and then they'll show a fire pump ahead of the main. Okay. Now, there is a policy where you can't tap the bus. You can't tap it. The contractor can't, because once that equipment leaves the factory, you can't do anything to modify it in the field, other than bring your electrical installation, like your electrical cables. You can do all of that work, but you can't remodify that panel board or that switchgear in any way, shape, or form. So tapping the bus is an absolute no. And if I see shavings, I know in the shape that it is in, I'm going to know. So you can't do that. And if you have to do that, that's a special design that should have been discussed prior to that switchgear getting on site. That should have been discussed ahead of time, because that can be done at the factory. With when you have something that needs to be tapped ahead of the bus, like a fire pump, that's what the engineers, they'll figure that out, and they'll do that at the factory for you. Now, let's say perhaps it did get overlooked, and now it needs to be done, because we're at the point where it has to be done. Whether it was overlooked or not, it must be done. That's when you contact the manufacturer and you tell them what you need, and they will be more than happy to come out there and make sure that their product is still under warranty. So to make sure that nothing happens while with their name on it, I'm quite sure. So they will do that for you. So this is so at this time, when I'm looking for that, I also ask about any other separately derived systems, such as generators and fire pumps that we spoke about, and I want to know about those, that type of equipment, just to make sure that those are another forms of services, because you have your service for the building, but a generator, that's a separately derived system as well. And I'm going to want to know if the neutral is switched, because that'll tell me a lot about that generator and what function that it will have for that building. So I will ask that question to make sure that the wiring methods and the needs are required. So now when I'm looking at your service, I'm going to ask you a few questions about the service. Some things I already know. And I'm going to look at the switch gear. I'm going to look at it in the overall service. I need to know, because this information has to go to the utility company. I need to know if it's a overhead or underground, and most likely a underground. I need to know the voltage. So if it's 120, 208, if it's 120, if it's 277, 480, I need to know the amps. I need to know, if it's 3,000, 4,000. I need to know if it's 1,000 amps. Those are things I need to know. I need to know if it's 3-phase, 4-wire. Those are things I need to know. And I just recently had one, just last week, where it was a grounded B-phase. Now, that's a subject on its own, but when I stated earlier that the equipment has to be suitable for use as service equipment, this grounded B phase is nothing to play about. And that's what we call it in our region, grounded B. But I have seen in other locations in our jurisdiction where they grounded the A phase. So that's just a term that we use. That's something that I can discuss at a later time if I get enough people that want to really know about it. Just email me, and I can get a subject about this going on. But the reason why the grounded B phase failed on the job last week was because it wasn't listed. It wasn't labeled as grounded B phase. So we need to know, because it's a certain way that it's hooked up from the manufacturer. They'll tell you per their instructions what to do and how to hook it up, how to tape it, how to phase it. They'll tell you all of that. But for any maintenance personnel or service person, when they come out on a job to do a service call, they need to know immediately if that's grounded B or if it's just a regular system. So that's very important. So I'll give more information about that if I get enough people inquiring. So once again, we're inside of the electrical room. We're doing the service inspection. So I'm looking at everything. I got to look at the overall system. I have to look at the layout of the room. And that's where the Article 11026, the working clearance issues, come into play. And I spoke about this in one of the segments a few weeks ago, where it seems that more and more these days, the electrical rooms are getting smaller and smaller and smaller. And they're cramming so much equipment in here that it's becoming a problem, because everything's on top of each other. So you got to take that into consideration, because when I get out there, sometimes I have to, the electrician, we got to pull out a code book, and we got to figure out how he needs to lay the room out. And that's not a part of the job, but I don't want him to fail, so I'll try to help as much as I can. But that should already be determined where that layout of that equipment is going to be. And you can determine that by reading Article 110.26 and looking at those standards. So one of the things that, like I mentioned, the larger equipment, if it's 1,200 amps or more, 6 feet wide, it has to have double the working clearance or 2 egress. That has been a problem on several jobs as of late. I have probably failed this type of issue probably 4 times a year. Now, that I've been doing it for a while, that's one of the first things I start. When I come on the job, I want to know the layout of that electrical room. We just go get the print and just figure it out right there, because that's a big cost. And once that electrical room is built and you did not account for a door, that's a problem. So keep that in mind and take that in consideration. Double the working clearance, or you need to have 2 egress. And when you have 2 egress, you can't have anything obstructing the passage out of the door. Nothing can obstruct that passage out of the door. So I want you to keep that in mind. And actually, this has happened, and this was about 2 weeks ago, a job. We're talking about obstructing the entrance for the egress door. And I'm not going to give the name of the gas station, but it was at a gas station. And the way they made the gas station service equipment, they had it on hinges. So where one of the egress doors were, the panel door swung where it opened 180 degrees, and it blocked the egress of getting out of the door. Can't do that, because if you're working in there and when you open the door and that your panel door blocked the egress door, how do you get out of there? So now they're going back to the drawing board, trying to figure it out. They did have one solution, so I'll let you know how that turned out. But keep that kind of stuff in mind, where the door is when you're designing this type of stuff, where the door is, because you can't open it to where you're blocking people inside. So that is actually a situation now. Okay, and I did just tell you about the obstruction of the egress, and some of those also could be, like I just stated, the door of the actual equipment. It can be columns, and it actually can be a bump out wall. Nothing can get in your way of getting out of that space. So just keep that in mind. Okay, and then something else I wanted to mention with this switch gear, the major switch gear, because you need to have above the switch gear, you have to have working space, and I think it's 6 feet. So anything that's above that switch gear, it needs to stay clear. So nothing should run over the switch gear in no type of way. And what normally causes a problem in that area would be sprinkler pipes. Sprinkler pipes could possibly bust and affect the gear beneath. That's an issue, and you're invading that working space above. So keep that in mind to keep the sprinkler pipes away from the electrical equipment. So and I spoke, okay, so the door swing of the actual door getting out of the electrical room. I spoke about that. That's been a problem. Just want to reiterate that. That's been a problem where you can't open the door from the inside. It has to swing out. So the objective there, if you have panic hardware on there, the panic hardware has to be listed. Remember that. It has to be listed, and it has to push out. And it has to be listed for fire exit hardware. So The objective is if you have a problem that you can push outward and you'll fall out of the door without using your hands. And if it's smoke filled without sight. So you just want to be able to push a bar to get out of the room. So just keep that in mind. So here's something. Are the service conductor size per requirements of the circuit breaker? Common issues. So the service 800 amps or more, you can use the next size breaker up. There's some discrepancies over that because it's 800 amps or more. So you can't have 801. So when you get to 800 amps or more, like sorry, I should have think about that. Well, it's 800 amps or more, and I'm actually going to look to see what's the next size breaker from 800 because I just didn't want to misspeak. So 1,000. So when you get there, or maybe you can have one specially made. I'm not sure. But now your conductors have to match. Everything has to match at that point. So conductor size in the circular mills, rating the I know where I'm going with that. So here's the problem that I've had with the conductors. The conductors going into a circuit breaker. So if you have a 1,000 amp circuit breaker, you're going to probably most likely have parallel feeders. So now what I've had issues with in the past, your circuit breaker tells you what size conductors can go into those terminals. So with that being said, if it tells you it's only large enough to fit a 500 circular mill, KC mill, if it tells you 500 only and you order out 750s, so this has failed inspections. You can't cut the strands. You can't cut around it and then put it in there. That's not allowed because you're damaging the conductor. And that's in Article 110, 14, up in there. But that's damaging the conductors. And then you're not installing it according to the manufacturer's instructions. The manufacturer told you to only put 500s in there, and now you come in with 750s for whatever reasons, and then you want to force the 750s in by damaging the conductors. Not allowed. What you can do, if you find yourself in that situation, what you can do is you can order reducing lugs from 750 to 500 or whatever size you need to reduce. So that's one of the methods that's approved that you can do. And besides cutting the conductors, because if you cut them and then you don't have enough slack, wow, that's a major problem. So remember, you cannot damage the conductors. And also, when these panels are being installed, you have to use the manufacturer's breakers. So whatever brand you have, use the manufacturer's breakers. Okay, so verify. Now, another thing I need to do, and I've done several times over and over, verify the overcurrent protection at the load end of the service entrance conductor. So now, I know we're turning on the power, but it just depends on the layout. It just depends. So why this question is important is because this has actually happened. So you have a service that came from the utility, and let's just call it a 2,000 amp service. Now you're going to feed a structure from a distance away. Just going to feed a structure. So I need to check both ends. I need to check the end where it comes into the utility and what it's feeding. So in this situation, we have a 2,000 amp breaker. And then the 2,000 amp breaker was feeding a 1,000 amp subpanel. So the problem came because the conductors were sized for 1,000 amps. But the 1,000 amps was on the receiving end, on the load end. So when you're sizing conductors, remember that you have to size the conductors in accordance to the breaker you're feeding from. And this was a large distance away. So they fed it. They had a 2,000 amp breaker going into the structure, feeding a 1,000 amp breaker. But they sized it according to the 1,000 amps. That happened. True story. I don't need to say any more there. Okay, so I'm getting short on time, but I want to mention this while we're here. One of the things that I've had issues with on service requirements for installation is torquing requirements. When we're inside and now I'm looking at your terminations and I want to see some markings. I should see some markings. So the National Electrical Code requires that the terminations be properly torqued using an approved method when the manufacturer provides specific torque values. Article 110.3b requires electrical equipment shall be installed and used in accordance with any instructions included in the listing and labelings. Now, I found in the 2020 code, Article 110.14d. Now, this isn't in the 2014, but this is what we're going to. So, 2014, Article 110.14d, terminal connection torque was modified to require proper torquing using an approved means. So incorrectly screwing terminals down without correct pressure can lead to terminal runaway, lost connections over time, causing high temperatures, which with the potential to cause an electrical fire. The torque values depends on a specific application. So when you're doing the terminals, it needs to be torqued. So how do I know? The only indication that I know that something's been torqued if it's marked. Usually they'll have a red marker or a black marker, and once they torque that pound, whatever the manufacturer told you to torque it to, you will do that, set it by the foot pound, and then you'll mark it off. And then when I come and I'll see a mark, and then that'll let me know that's an indication that it's been torqued. But now if I don't see that mark, I'll question it. And most of the time, the electrician will say, oh, we sent that torque wrench back to the shop. Well, you need to get it back because that's such a severe issue that I need to check that before I sign off on it. So just keep that in mind when you call for a service installation inspection to keep your torque wrench on site, because I need to verify that. And we can figure that out by looking on the breaker to look to see what the terminals, what size, how many foot-pounds do they want you to torque that at, and it'll tell you that on the breaker. This is what I want to get in before I end this today, and then I'm going to pick back up next week with other sections, because this is just the tip of the iceberg, and I don't want to keep you too long because I want to keep your attention. So this is something that has failed constantly. I get this probably twice a week if I go on a service call, on a service inspection. Lashing. Service, I get that a lot. So you may ask yourself, what is lashing? Because I've had electricians ask me that. They'll say, well, they never heard of that. To be honest, before I was an inspector, I hadn't either, to be honest. So what is lashing? Lashing is a common requirement when available fault current exceeds 65 kA. High current in a fault can create magnetic field that can cause cables to whip around, damaging the switchgear and the cables. The cable lashing stabilizes the cable to reduce movement and to protect the equipment and to prevent it from being damaged. So the resulting issue from unlashing cables without rapid movement equipment failure can cause equipment failure, includes but not limited to. So if you don't lash your cables and you have a fault current and it whip around in the gear and it could damage the gear, but what it can also do is pull the cables out of the lugs. It can bend the cables and the lug adapters. It can break the bus bar material, and it can damage the cable installation. So the equipment damage can cause the gear to not operate properly, and the resulting safety concerns such as arc flash. So what equipment needs to be lashed? Where is it required? The CT can. If you look at that CT can, and the CT can is the current transformer. If you look at it before you put your wires in there, your conductors in there, you will see a drawing on there showing you, telling you, giving you details on how to lash and what to do in the CT can. Also, in your service manual, your installation instructions for your switch gear, it also has that in there. Now, that's not a diagram that's on the actual switch gear, but most of the time when I see that information, it's in that pamphlet. It's in that book. And it tells you how to lash. It tells you what to do. So what told you is the CT can and the switch gear, the panels. And another question that the electricians ask, well, what do we use? What do we use to lash with? What I've seen commonly used in the field is nylon rope or mule tape. And in the field, you know what mule tape is, and that's the most common thing that is used. Now, the manufacturer instruction guides will provide instructions on the method and the pattern you should follow. So read those instructions and make sure that your CT can, I have yet to find a CT can that doesn't have that in there. And now it does depend on how your wires are laying in there, but read that CT can because it actually has a picture and it shows you what you need to do. So I'm going to cut it right there, and I'm going to pick up next week. I do want to get a question in that a homeowner sent, and I just want to get that question in because I have put it off for maybe a week or so. So if you have electrical work done in your home and something doesn't work correctly, would you see the effects immediately? That's a yes and a no question. It just depends on what was installed. Now, if someone installed a ceiling fan or a light and it doesn't work, yeah, you will know the effects immediately. But like as I spoke earlier with terminations and how loose connections could cause problems, if someone installed some receptacles in your home, and depending on how tight the connections are, that's something that probably could take some time to work out. So because it takes time, vibration could cause a connection to become loosened. And over time, if it vibrates, that connection can become loose, and that could cause a problem. But now you probably had this done 3 years ago. But you don't know that until you troubleshoot and figure out what actually happened. Now, when I'm talking about the terminations, this is something that I saw when I installed a ceiling fan a few years ago, and I mean a few years ago. I went into someone's home and I was the ceiling fan had went out. And so they said that it had sparked before it went out. So they bought a new one, and I was going to install the new ceiling fan. So upon removing the ceiling fan and looking at it and figuring out what went on, what happened was they actually tightened the wire connector so tight that it actually came through the wire nut, is what we call it, the wire nut. And the metal the metal conductor was sticking through. And that ceiling fan, they said it worked for a long time. But the problem was the right condition. Now, that metal eventually touched the metal box and blew and sparked. And actually, it wasn't the fan, it was the connection. So it just depends on what is being installed and how they install it. You could know immediately and perhaps not. It just depends. But if anything electrically happened, the fire marshal, they'll figure that out. So if it's something that crucial, it's just one of those things. It's possible, and it either going to work or not, but it can work out through time. So that's something you just have to, as a homeowner, do your homework. As a homeowner, check the Better Business Bureau. Also, make sure that you get look at reviews and make sure that if that's something that you want to hire that electrical contractor, check around to make sure that that person is reliable and that they don't have a lot of bad reviews. So I wanted to make sure I answered that for the homeowner because they have been really helpful in this process. So as always, if you have any questions or comments, please contact me on social media, Facebook, Instagram, X, YouTube, under the moniker Ask the Lady Electrical Inspector. If you would like to add anything to this discussion or provide feedback, email me at asktheladyelectricalinspector@gmail.com. And with any questions or electrical concerns. Thank you and good night.